So now we are going to discuss about riveted gear train. So already we discussed the compound gear train can be subdivided into two categories. One is riveted gear train, another one is non-riveted gear train, right? So riveted gear train, which means when the axis of the first gear and the last gear are coaxial, then this type of combinations or this type of gear trains is called as a riveted gear train. See the picture, 4 gears are there. The gear 1, the gear 1 and gear 4 both are coaxial, right? See, this is shaft 1 and shaft 2 and shaft 3, right? So 3 shafts are there. Shaft 1 it carries gear 1 and shaft 2 it carries gear 2 and gear 3, whereas shaft 3 it carries gear 4, right? So the gear 1 is meshed with gear 2 and gear 2 and gear 3 both are in the same shaft. Then the gear 3 is meshed with gear 4 and gear 1 and gear 4 both are coaxial. Then this type of combination is called as riveted gear train. Now then what is meant by non-riveted gear train? See, the first and last gears are non-coaxial, not coaxial, then that type of combinations are called as non-riveted gear trains. Then how to calculate the velocity ratio for this riveted gear train? The velocity ratio, which is equal to the product of number of teeth on driver divided by the product of number of teeth on driven, right? See, N4 divided by N1, which is equal to T1 by T2 and T3 by T4. How this equation we got? See, N4 divided by N1, which is equal to T1 by T2 into T3 by T4, right? So how this we got, right? So now see, N1 is meshed with N2, right? And N2, N3 are same. Now N3 is meshed with N4, which is equal to T2 divided by T1 into T4 divided by T3. This is the equation. Now N2, N3 both are in the same speed, then which is cancelled. Now N4 divided by N1, which is equal to T1 by T2 into T3 by T4. So this is the calculation. This is how we got this relation, right? So now the same one, R1 plus R2, which is equal to R3 plus R4. See, this is the center. This is the center of the gear 1 and gear 4, and this is the center of gear 2 and gear 3, right? So what is the distance between this? Both are same, right? See, R1 is this one. So R1 is meshed with gear 2, right? So R1 plus R2, which is equal to the gear 4 is meshed with gear 3 and which is equal to R3 plus R4, right? So this is the equation, right? See, similarly, teeth T1 plus T2, which is equal to, see here, R1 T1, R2 T2, which is equal to T3 plus T4, R3 T3 and R4 T4. Clear? So this is how we got this equation, right? Now epicyclic gear train. Epicyclic gear train. What is meant by epicyclic gear train? When the axis of rotation of one or more gears is allowed to rotate about the another axis. See, for example, here the two axes are there, O1 and O2, right? Suppose if the gear A is fixed, then the total setup, I mean arm C and gear B, it rotates with respect to O and gear B rotates with respect to O2. Right? If suppose the arm C is fixed, then the gear A it rotates about O1 and gear B rotates about with respect to O2, right? What is the difference between epicyclic gear train and other gear trains? Right? What is the difference? In case of simple and compound gear trains, simple and compound riveted gear trains, the axis on which the gears are mounted are fixed, right? There is no relative motions between each other, whereas for epicyclic gear train, the axis of the shaft on which the gears are mounted or may have the relative motion. That's why here arm C rotates with respect to O1 and the gear B it rotates about O2 and O1. Clear? So that's why when the axis of rotation of one or more gear is allowed to rotate about the another axis, then this type of gear trains are called as epicyclic gear train, right? Now types of epicyclic gear trains. So already we discussed types of epicyclic gear trains. One is simple gear train, another one is compound epicyclic gear train, right? So when there is only one gear on each shaft, right? So here only one gear and the gear A is also one gear, right? So when there is only one gear on each shaft in any epicyclic gear train, then that is called as a simple epicyclic gear train, right? Whereas compound epicyclic gear train, what is meant by compound? Before that, simple epicyclic gear train, see the picture here, the arm C, it carries only one gear A, and here this side arm C, it carries only one gear, right? So one gear on each shaft, right? See, whereas for here A which is equal to sun gear and B which is equal to planet gear, C which is equal to arm, this is arm, this arm carries two gears each end, one is one end and another gear in the another end, right? See here O1 is fixed and O2 is moving, right? If suppose A is fixed, then automatically the arm C and gear B rotates. Arm C rotates about O1 axis and gear B rotates O1 and O2 axis. Clear? Why? Because this arm B, arm C, it carries the gear B. Clear? So sun gear is nothing but the gear at the center whose the axis is fixed. Here the axis of A is fixed, that's why this is called as sun gear. And what is meant by planet gear? What planets are doing? The planets are rotating itself and it rotates about the sun, right? Similarly here the gear B whose axis moves is called the planet gears with respect to the axis of sun gear, right? Then arm is nothing but it carries a planet gear and is free to rotate or revolve about the fixed axis, right? Two cases are there. One is A is fixed, then the arm is rotates. If arm is fixed, then A is rotating. Clear? The second case is compound gear trains. The compound gear trains, when there are more than one gear on the shaft, then this type of combinations are called as compound epicyclic gear trains. See, so it's a simple problem. Two parallel shafts are to be connected by spur gear. The approximate distance between the shaft is 600 mm. If one shaft runs at 120 rpm and another at 360 rpm, find the number of teeth on each wheel. If module is 8 mm, also determine the exact center distance between the shaft, right? So what are the given data available? First we should write the given data. The center distance already given, C, which is equal to 600 mm, and if the one shaft runs at 120 rpm and another at 360 rpm, right? So let us take the 120 which is equal to N1, so N1 which is equal to 120 rpm and N2 which is equal to 360 rpm, right? And find the number of teeth on each wheel. So we have to calculate T1 and T2, right? So T1 and T2 we need to calculate, right? If the module is 8 mm, so module is also given, so M which is equal to 8 mm module, and also determine the exact center distance. So C, again we need to find C after this T1 T2, after the calculation of this T1 T2, right? So let us start. So we know that already the formula for center distance, right? C which is equal to D1 plus D2 divided by 2, right? So center distance is nothing but, see here the gear 1 and this is gear 2, right? So gear 1 and gear 2 both are meshed with each other, right? And this is the diameter of gear 1 and this is the diameter of gear 2. This is D1 and this is D2, right? Center distance is nothing but the distance between the two axes, which is called as center distance, right? So which means here from this point to this point, which is called as radius R1, and from this point to this point R2, right? So that's why D1 plus D2 divided by 2, right? RC which is equal to R1 plus R2. Either we can use these two, either this formula or this formula, right? So now we are going to use this C which is equal to, so D1 plus d2 divided by 2, right. So, d1 which is equal to diameter of this gear 1 and d2 which is equal to diameter of gear 2, right. So, center distance already given, which is equal to 600 mm. So, here 600 which is equal to d1 plus d2 divided by 2. Then this equation became d1 plus d2 which is equal to 2 into 600. So, which is equal to 1200. So, d1 plus d2 which is equal to 1200. This is equation 1 we got, right. So, we need to formulate one more equation. So, we know that the formula n2 divided by n1 which is equal to t1 divided by t2, right. So, now, so this will become t1 by t2 which is equal to, so n2 is given, n1 is also given. So, how much n2 which is equal to 360 divided by, so t1 which is equal to how much, t1 which is equal to 120, right. So, 120. So, how much this is, which is equal to 3 12s are 36, right. So, t1 which is equal to 3 times of t2, right. This is another equation, clear. So, now module is also given, module, right. So, module which is equal to, we know that how much, 8 mm, right. So, we know the formula also, module. So, m which is equal to small d by t, right, or t. This is small d, small t, capital D, capital T, right. So, for this, so module already we know that 8 mm, right. So, module which is equal to 8 mm, already we know that. So, now this become d1 which is equal to 8 into t1 and d2 which is equal to 8 into t2, right. So, substitute this d1 divided by t1 or d2 divided by t2 which is equal to 8. So, d2 which is equal to 8 into t2, d1 which is equal to 8 into t1, right. So, this is the final formula, right. So, now substitute the values. So, now d1 which is equal to 8 t1, d2 which is equal to 8 t2. So, use these two values in this equation, right. So, now 8 t1 plus 8 t2 which is equal to 1200. This is one equation, right. So, now t1 plus t2 which is equal to 1200 divided by 8 equal to 150, right. This is 150. So, t1 plus t2 which is equal to 150, clear. So, we know that here t1 which is equal to 3 t2. So, substitute t1 value in terms of t2. So, t1 which is equal to 3 t2 plus t2 which is equal to 150 and now 3 t1 plus t2 which is equal to 4 t2 which is equal to 150. Now, t2 which is equal to 150 divided by 4, right, which is equal to how much, 150 divided by 4 which is equal to 37.5, right. So, 37.5 say approximately 38 teeth, right. So, teeth in terms of 0.5 is not allowed, right. So, T2 which is equal to 38. Substitute this T2 value in this equation, then you will get T1. So, T1 which is equal to 3 into 38. So, T1 which is equal to how much, 38 into 3 which is equal to 114, right, 114. So, this is the value of T1. Now, we need to find C, right. So, what is the formula for C? C which is equal to D1 plus D2 divided by 2, right. So, we need to calculate D1, D2. D1 we know that formula 8 into T1, D2 which is equal to 8 into T2. Substitute T1, T2 value what we got and finally substitute the value of d1 d2. So, d1 which is equal to how much? 8 into 114, then we got 1912 plus d2 how much? 8 into 38, which is equal to 304 divided by 2. So, which is equal to how much? 608, okay, mm, which is equal to 0.608 meter. That's it. Let me check the answer. Clear? So, T1 which is equal to 114 and T2 which is equal to 38 teeth and D1 which is equal to 912 and D2 which is equal to 304, and finally what we got? C, center distance which is equal to 608 mm. Right? Clear? Thank you.